Hello friends and welcome back to the channel. This is conic section part 4. In this part we're going to discuss about degenerate conic. So without wasting any time, let's get started. In the first conic section lecture, we have learned that if a conic section is divided parallel to its base, or the section is made of a right circular cone that is parallel to the base of the cone, we get a circle. When it is parallel to generator, we get parabola. When it is parallel to the axis, we get hyperbola. And when it is not parallel to any of the three given terms, generator, axis and base, we get ellipse. But if we cut the right circular cone from its vertex, what will we get? We will get pair of straight lines. As you can see in the given figure that V is the vertex, and if we cut the cone from the vertex, we can get, or we are getting in the given figure, VA and VB as pair of straight lines. So we need to first understand that by cutting a cone or a right circular cone from the vertex, we get a pair of straight lines which will always pass through the vertex of the cone. Now we come to the term degenerate conic. In chemistry, we know that degenerate word is used for degenerate orbitals, that is same energy levels. So for degenerate conic, what we get is we get the equations or the nature of conic just in the form of straight lines. That is, all the nature of the conics are related to pair of straight lines. And secondly, since it is the opposite of non-degenerate conic, one factor which distinguishes between them is the value of determinant. So, we know that the general equation of conic is of the form ax squared plus 2hxy plus by squared plus 2gx plus 2fy plus c, and the value of determinant for this conic section, which is represented by s, is delta, which is equal to all hot girls having boyfriend go for coffee. AHG, HBF, GFC are the terms in the determinant, and when this determinant is equal to 0, we get degenerate conic. So, when delta is equal to 0, we get 4 different nature of conic, or 4 different degenerate conic. Now, as in the case of non-degenerate conic, there was just one condition on which we found out the nature of conic, and that condition was AB minus h square. And similarly, for degenerate conic, we do have the same condition, but the values are not same. AB minus h square, when it is equal to 0, we get pair of coincident lines. For AB minus h square not equal to 0, we get pair of intersecting lines. For AB minus h square is less than 0, we get real or imaginary pair of straight lines. And for AB minus h square is greater than 0, we get a single point. Pair of coincident lines mean this is a straight line. Again, coincident line means they coincide. Pair of intersecting line means they intersect at a given point. Real or imaginary pair of lines, we get lines in the Argand plane, and AB minus h square greater than 0, we get a single point. So this is all for degenerate conic, and this is the nature of conic with the condition being AB minus h square equal, not equal, less or greater than 0. So this is all about degenerate conic. I hope you learned what it is, and I hope you enjoyed the video. This is Yojit Bhasin signing off from T7T. Thank you guys for watching. Meet you in the next lecture. Thank you.